Welcome to my webinar today. I'm very pleased that you have taken the time to get an insight into our world. I can see on the list that some of you already know the composite world, but hopefully you will all get some new information during this presentation, and you can always find a lot more information on our webpage. I would like to talk about the different possibilities with glass fiber reinforced polyester, or FRP, what we also call it. In this presentation, I'll show you a lot of slides, and I will also dive into some of the details. So find yourself a cup of coffee and a comfortable chair. And please, if you have any questions during the presentation, please send it immediately, and I'll try to give you an answer after the presentation. Just need to. Sorry for that. I would like to address the following themes today, but in my opinion, it's important first to talk about the basics of the products before we move into the topics of today. But I'll start with a small presentation of Fiberline building profiles and of course myself. Fiberline Building Profiles is a family-owned company. It was founded by Henrik and Dorte Thorning in 1979. So for more than 40 years, we have been pultruding glass and carbon fiber profiles. Today, we are divided into two companies taking care of two industries. One company is supplying the wind industry and the other company is supplying the building industry. Our sister company, Fiberline Composites, is mainly producing carbon, but also glass, and we, Fiberline Building Profiles, is mainly producing glass fiber profiles. And who is your presenter? Yeah, that's me. My name is Tage Frank Namnord Jensen. I'm a key account manager here at Fiberline Building Profiles. My education was made by VIA University in Horsens in 1995. I graduated there, and I've been working here at Fiberline for more than 15 years. Today, I'm responsible for some of our key accounts, and I have focused on sales of our bridges in Scandinavia. Privately, I'm married to Panarat, and I have 3 grown-up sons. And as you see on the picture, I'm a very passionate cyclist. By the way, the picture is taken at the longest distance run here in Denmark, which is from Aarhus to Copenhagen, or 380 kilometers long. And now let's talk about a bit of the basic and also about the product range today. A Fiberline building profiles, a profile consists of approximately 60% of glass and 40% of resin. The dry raw material is primarily glass, but it can also be carbon or aramide fibers. But you can also use natural fibers such as wool and hemp. The wet material or the resin material can be either polyester, polyurethane, epoxy, or similar products. If you look at the different glass types, UD is a unidirectional rowing type and is providing the strength in the longitudinal direction. The spun and the mock also provides the strength mainly in the longitudinal direction, but also a bit in the transversal directions. The mats, you see on the down of the picture, are mechanical made, random orientated, continuous fibers. They have good all-round properties like transversal strength, stiffness, and bolt-bearing capacity, and gives also a high impact resistance. All the construction profiles are produced with a surface wheel for increased corrosion resistance, weather and UV resistance. The surface wheel also improves the surface appearance. Similar to steel construction profiles, our range of construction profiles include more or less the same shapes. The FRP cross sections were developed and optimized together with the glass fiber package. And you can find the entire product range on our webpage. We normally keep 6 and 12 meter lengths in stock, and all information like load tables, technical drawings like DVD or step drawings can be downloaded free of charge on our website. You just need to log into the web shop, and here you can also place an order 24/7. You can see your own history if you are a customer here. You can save your favorites, and there's a lot of more things you can do. If you're a new customer and working on a bigger project, you can also always contact our sales team before placing an order. Please use, if possible, our standard profiles as they are always in stock. Customized products and non-standard items have a minimum order volume that must be agreed with us before we start up the production. You can even buy a complete bridge on our webpage if you want to. We have a standard size, the one you see on the picture here, 6 by 12 meters. But if you don't want to buy a complete bridge, we can also offer bridge decking planks, mainly for pedestrian and bicycle bridges. We keep the deckings in 6 and 13 meter stock. Planks can be supplied with anti-surface skid rated R10 to R13 according to the DIN norm, or a slip resistance value according to the EN norm. Planks are of course also available without anti-skid surface. We offer painting in different colors, and all fittings, balls, screws and other accessories are of course made in stainless steel. The heavy-duty plank you see in the middle is suitable for applications where the load requirements is approximately 5 kilonewton per square meter and with a point load of maximum 10 kilonewton, which means it must be decks for bike path and pedestrian bridges. The ultra duty plank right in the top is our strongest bridge decking, designed to meet our most strict load requirement for pedestrian and bicycle bridges. On this type of bridge deck, you can even drive with vehicles up to 12 tons. In addition to all the construction profiles and planks, we also offer FRP gratings. For all our products, you can download brochures and load-bearing charts from our webpage. All the accessories here are also made in stainless steel. Now we come to talk about different kind of machining. Cutting. We can do the cutting for you, but if you want to do the cut in the FRP profiles yourself, we recommend that you use a circular saw or a chop saw. We recommend the use of carbide or diamond tipped saw blades, and you can either use mobile or stationary systems. Dust is not harmful from the cutting. It's not harmful to your body because of the size. However, we recommend that you use a face mask, hearing protection, and of course safety goggles. After work, you should wash your hands using only cold water, because the pores in your hands opens up when you use warm water, and when the pores are open, the small pieces of glass will get into the pores, which causes itching and irritation to you. Jigsaw equipped with a carbide saw blade for sheet metal work is very good for creating curves in the FRP profiles. When we use our CNC machine for cutting, the optimal speed is approximately 60 to 80 millimeter per second, but a lower speed, of course, will reduce the tool wear. For larger series, we will recommend that you use diamond-tipped saw blades. We normally buy our cutting tools from a German supplier based near Frankfurt am Main, but I'm sure there are many other suppliers out there. Drilling. For smaller jobs, ordinary wood drill bits or hard metal drill bits can be used. For larger series, special drills or diamond tip drills are much better. We use normal machines such as cordless screwdrivers, but also column drills with a speed of between 1600, 3600 and 3900 revolves per minute can be used. This speed gives of course burr-free holes in the top and in the bottom. We also use other different kind of mobile drill machines, so you can just probably use the one that you already have in house for drilling. I'm a bit unsecure if the translation is correct, but you are probably familiar with all the different kind of drills. The first one we call a river drill, and then the second one is a cone drill or countersink drill, and the third one is a carbide drill, and then we have a fourth as a special drill, and 5 is the Forster drill. For grinding the profiles after cutting, sandpaper or Scotch-Brite is suitable. A belt grinding machine with a high speed and a low feed rate are also perfect for larger series. When we use our CNC machine for machining, for milling and drilling, we use carbide or diamond tipped tools. The rake angle should be between 5 and 15 degrees. Here you should pay attention to the feed rate. We use approximately 0.5 millimeter per revolution. Cutting speed up to 16 millimeter per second is optimal here. If we feed too much, the result will be worsened by case of overheating of the material. Punching the FRP profiles is also possible. A wall thickness up to 4 millimeters can be punched with normal carbide punches, but please note that punched holes will shrink approximately 0.05 to 0.1 millimeter compared to the punch size. The cutting angle should also be flatter compared to steel, and this of course will lead to an increased wear of the tool compared to steel. So punching is possible, but it's not the best solution. Cutted threads in FRP cannot withstand greater loads and are therefore not recommended. We have tried in many different ways, but the results have never been really good, so we recommend you to use alternatives. Water jet cutting and laser cutting. Panels and solid profiles up to a wall thickness of 20 millimeter can be water jet cut. Laser cutting is also possible by using protective glass, could be argon. Pressure and speed must be much lower than by steel cutting. Milling in the latter. Carbide or diamond tipped tools should be used when turning and milling in the same time. The feed can be up to 0.5 millimeter per revolution and the speed up to 60 millimeter per second. The clamping angle of the cutting edge is between 10 and 15 degrees to achieve the best result. Depending on the tool, the cutting depth can be up to 10 millimeter. We learned in our own production that we will get the best finish with rounded tool bits and air cooling or liquid cooling, one of the two, either air or liquid cooling. Next one we're going to talk about is assembly. Bolted joints are used in many different applications, such as cooling towers, bridges, in the building industry, in the chemical industry, plant engineering, offshore installation, and of course railway platforms, stairs, and many, many more. In the near future, DB certificates will be required for the assembled FRP profiles construction in Germany. However, there will still be a transition period for this. This will be regulated in the Deutsche Bahn standard and of course will be organized by the Academy for Railway Systems. In Denmark, we sometimes follow the rules that are introduced elsewhere, but all their load-bearing structures naturally require an approved calculation. And it might be different from country to country, but I'm sure you know the best what the rules are in your own country. Mechanical joints, machine screws and washers with self-locking nuts are recommended to be used in here. If you want to dismantle screw connections, sleeves can also be used. This is a screenshot from our German approval where you can see the distances to the edge of the profile and the screw size, as well as tightening torque and regulated in the German type approval. You can also find the same information in our Fiberliner design manual. All screws connection should be tightened after 24 hours. But please get back to us if you have any questions regarding where to place the hole and how to tighten the bolts and things like that. We will be glad to help you here. Some mechanical joints and rivets, threaded inset sleeves and rivet connections are recommended for smaller wall thickness. However, rivet joints are also used to apply pressure for adhesive joints. When using rivets, please note the information provided by the rivet manufacturer with regards to drilling hole diameter and of course the tools required. This is from an earlier test of a Bossard screw. Self-tapping screws can be used but cannot be untightened and tightened again. Here you see the maximal tightened torque is about 3 Newton per meter with a 6.3 millimeter wide threaded screw. These values apply to this screw and may be different from the different manufacturers. I would like to use a bit more time on the glued joints because glue has many advantages. It's easy to make anesthetic joints. Glued joints between profiles are typically more rigid than traditional bolted joints. Some type of glue are extremely strong, making it possible to limit the extent of contact areas. And glued joints are subjective to dynamic loads are good. However, it's necessary to consider a number of conditions in using glued joints. A number of adhesive agents have properties that depend on time and are influenced by environmental factors such as the humidity and the chemical compositions on the air. Failure in glued joints take place suddenly in contrast to bolted joints. The load-bearing capacity of glued joints is not proportional to the area which is glued. The load-bearing capacity of specific joints only increases with the glued area to a certain point, after which it remains constant for the glued area. This condition is due to the fact that fracture is connected with a certain tension in the adhesive layer, typically in the transition from the one profile to the other. Because of failure in glued joints occurs suddenly, joints in load-bearing structures are normally secured with bolts. In many cases, an adhesive is applied to the contact surface between the joint profiles, thus increasing the rigidity of the joints in operation. Glued joints have many advantages in comparison with bolted joints. Around the world, intensive research has been carried out in the mode of operation of glued joints. When sufficient knowledge becomes available, advanced verification of tests will be unnecessary, and glued joints will be undoubtedly find our primary joints in bearing structures. Fiberline takes active part in this research process. On the next page, you can see a all different kind of glued joints. For load-bearing structure, use a two-component epoxy or polyurethane glue by following the instructions made by the authorized supplier. And here you see some of the things you have to use by glued joints. Grinding and cleaning the surface is of course necessary as a preparation before you glue the material together. It's important to follow the instructions from the supplier and make sure that the surroundings are good and the temperature is high enough. Apply the glue with a filling knife or a roll. Put the two parts together and put pressure on the joint by using a sandbag or other heavy stuff. And here again you see a picture of a glued connection in combination with bolts. And as mentioned earlier, it's an excellent way to secure the connections at the moment. Here you have to prepare the holes before you prepare the gluing because they are aware of the curing time of the glue. On the next few slides, I'll show you the comparison between a mechanical and a glued connection and the failure of the two different connections. On this slide, you can see the schematic presentation of the test setup of a cantilever with a load instruction. I just needed to sip some water before I continue. Here you can see the individual profiles were glued according to the specifications of the manufacturer Sicadur. In this case, we used a two-component epoxy adhesive Sicadur 330 here. On the left side, you can see the glued connections, and for the comparison, the test setup was a pure screw connection on the right side. With the glued connection, we get an interlaminar shear failure in the FRP profile and not in the adhesive. For the bolted connection, a bearing failure can be seen in the screw connections. It might be a bit difficult to see in the small picture, but down to the left you can see in which direction the hole was broken. Here's the test made between two bridges, and the failure moment of the bonded joint was 33.5% of the maximum moment capacity of the beam. The value is at least 80% higher than any other compound tested in the past. Now we're going to talk a bit about painting the profiles. Due to the weather changes, the surface on the profiles can become rough over the time, making it easier for dirt to settle on the surface of the profiles and affecting the aesthetics of the construction. All our FRP profiles and planks have a surface polyester mat with a thickness of 0.4 millimeter, which keep the main supporting fibers, in this case it will normally be the mats, away from the surface. The main supporting fibers are therefore not attacked and the mechanical properties remain intact. Therefore, it is recommended to use a color coating of 60 μ dry. The coating system will not affect the durability, but rather ensure the attractiveness of the profiles for decades. Now, a bit about repairment of constructions. If the profiles can be cleaned with ordinary cleaning agents, you can also use a high pressure cleaner, but don't go too close to the profiles, otherwise you will damage the surface. Bolt joints can be inspected visually and possibly retightened if needed. If it's necessary to repair parts in the construction, we recommend you to contact us or any other designer, FRP engineer, or any other FRP supplier. In the picture, you can see what equipment you need to use to perform a minor surface repair. How to do the surface repair will be shown on the next slide. It's a repair of a scratch. You can grind the surface with sandpaper 180. You can fill the scratch with a suitable filler, could be Cicadur 330, and then again grind the dry surface with sandpaper 240. The profile is now ready for painting. If you want to repair a hole in the profile, you need to drill a hole with a cone drill and make a cone and align the cone with the hole. Glue the cone into the hole, but make sure that the cone is slightly below the surface of the profile. And then you can fill up the hole with a suitable filler. Grind the connections with sandpaper 240, and then again it's ready for painting. Inspections. Inspections can be performed visually. This is inside a cooling tower, so you might turn on the systems before a visual inspection. And in this visual inspection, you can check the surfaces of the profiles. You can see if there's any deformations, have there been any vandalism, accidents, or delamination, or other things like that. Bolt joints must be retightened according to the instructions, and there may be some special regional requirements. I do not know them, but I'm sure you know them where you live. Now we come to the last slide in my presentation. If you want to get in touch with some pultruded profiles from Fiberliner Building Profiles, you can order different sample boxes on our webpage. And today you'll get a 50% discount on a sample box. The sample boxes contain several different cross sections and all in 20 centimeter length. If you are interested in buying longer profiles, you can go to our webpage. Here you can find all our standard construction profiles up to 15 meters long profiles. And now it's time for questions, if there is any questions. And here I have to reach out to you. Louise, have there been any questions coming in during the presentation?
Hi, Terje.
Hi, Louise.
Yes, we have a question here. Somebody's asking, can GRP be powder coated?
No, it's not possible to powder coat the GRP profiles immediately because there's no electrical it's not leading any electrical, so it's not possible to powder coat it. Sorry, you have to use 2-component wet lac like to use on cars.
And another question goes, how do I dispose of leftover GRP materials?
Well, normally it can be handed in the local landfill. In our production, we normally recycle it in a production cement in Germany. So this is how we do with the leftovers, but it can be handed in the local landfill.
And a question from Brian, is there a webinar on installing GRP planks as we have a bridge deck to install?
I don't know if it's planned yet, but otherwise you can get directly in contact with us, and we will be gladly to help you by an instruction for that.
One more question. How do you prevent resins from UV deterioration?
In the resin, there is an additive that protects again the UV degradation of the profiles. So it's an additive added into the resin. And you can, the second thing you can do, you can also paint it, then you have a double protection.
Okay, one more question. Somebody writes here, thanks for your presentation. My question is it suitable to use normal concrete layer over FRP deck?
It's not, you cannot use it directly because the concrete will then go into the FRP profiles. You have to paint the profiles before you put them into the concrete.
And one question, and it's about bolting. Is there, from FRP point of view, any preferences for stainless steel bolts or galvanized bolts?
No, not really. We normally used to use stainless steel, but now since the steel prices has gone up due to many reasons, we also do some galvanized as well.
And Simon wants to know, regarding drilling, what is the best drill carbon or diamond?
Diamond. I would say diamond is the best one. Diamond tools last longer.
Somebody here writes, so we do not need to select any special resin to make sure they will not deteriorate from UV exposure.
No, it's a job we already have done for you.
And one more. A guy called Bart is asking, for bolted connections, how do you mitigate the risk of compressing resulting from the tension? Do you use lower torque?
Yes, we do normally, yes.
That's it. We just got a smile from Simon.
Okay, thank you, Simon. And thank you to all the rest of you as well. Thank you for listening to this webinar and have a great day.